Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. In this video, we're going to go over some basic building blocks on how to work with logs. So much like how we had exponent laws to deal with exponential equations, we have a similar set of log laws to assist us in handling logs. Today, we'll break down the four main log laws: the product, quotient, power, and change of base rule, all in simple, digestible steps with easy examples. So let's get started. The product rule states that if we have log base c of a plus log base c of b, that is equal to log base c of a times b. And the important thing to note here is that we have to have the same base. So in this example, we have base c for both of these logs. The quotient rule is very similar, but instead of a plus, we have a minus. So we would have log base c of a minus log base c of b, and instead of multiplying them like the product rule, we end up getting log base c of a divided by b. And again, notice how we have to have the same base c. So this means if we have two logs with different bases, then we cannot combine them this way. One thing you might notice is that this looks quite similar to our exponent law. So we also had a product and quotient rule for exponent laws. And it was if we had the same base and we're multiplying two exponential expressions, all we had to do was add the exponents. So now let's take a look at how to use these two rules in practice. So we want to evaluate log base 2 of 8 times 4 and log base 3 of 81 divided by 9. So let's first rewrite log base 2 of 8 times 4 using our product rule. So we have log base 2 of 8 times 4, and we're going to split this up into two logs. So essentially, we're going from the right side of the equation to the left side. So this ends up being log base 2 of 8 plus log base 2 of 4. And if you recall the previous video where we introduced the definition of a log, we can think of this as if we want to evaluate what log base 2 of 8 is, we're asking ourselves 2 to the power of what is going to give us 8? And 2 to the power of 3 is equal to 8. So log base 2 of 8 is equal to 3. And log base 2 of 4 is going to be equal to 2 because 2 to the power of 2 is equal to 4. So we end up with 5. And now for the second expression, we will be using the quotient rule. So we have log base 3 of 81 divided by 9. So again, we can rewrite this into two logs, which will be log base 3 of 81 minus log base 3 of 9. Using the definition of log, we're asking ourselves 3 to the power of what is going to give us 81? And that's going to be 4. And 3 to the power of 2 is going to give us 9, so the second expression is equal to 2. And now we have 4 minus 2, which is just equal to 2. So looking at this expression here, you might ask, why can't we just do 81 divided by 9, because that's equal to 9, and then we just find log base 3 of 9. Of course you can do that, but we're only doing this to illustrate how to actually use the quotient rule. So the next rule that we're going to talk about is the power rule. And the power rule states that if we have log base a of b to the power of n, then we can actually bring the exponent down and it becomes n times log base a of b. So one very important point here is that log base a of b to the power of n, b to the power of n is the input that we're putting into this log function. So this is what we mean by log base a of b to the power of n. And this is not the same as log base a of b all to the power of n. So if you see something like this part here, then we cannot use the power rule. Power rule only applies when the exponent is inside the log. So now let's go ahead and use this rule to evaluate log base 5 of 25 to the power of 3. So here, essentially, we have 25 to the power of 3 in brackets. And of course, we don't want to do 25 to the power of 3 because that turns out to be a really large number. So applying the power rule here will simplify this. So the power rule tells us that if we have log base 5 of 25 to the power of 3, we can actually go ahead and bring the exponent in front of the log. So this becomes 3 times log base 5 of 25. And now we just have to ask ourselves what log base 5 of 25 is. And to do that, we can think back on the definition of logs again and ask ourselves 5 to the power of what is going to give us 25. And that is going to be 2. So this becomes 3 times 2, and that is going to equal to 6. So this question is going to require a little bit more thinking. We're given that log 3 is equal to a, and log 2 is equal to b. So again, remember that if you don't see a base, it just means that it's base 10. And what we want to do is we want to write log 36 in terms of a and b. So we don't actually want to find a decimal number for log 36. We just want to write it in terms of a and b. So that tells us we want to break down log 36 into components of log 3 and log 2. So we start with log 36, and we know that 36 can be written as 9 times 4. So we're going to write this as equal to log of 9 times 4. And now 9 is just 3 to the power of 2. And 4 is 2 to the power of 2. So that means we can write this as log of 3 squared times 2 squared. So all of this is just algebraic manipulation. We haven't used any log rules yet. But now we're going to use our first log rule, which is the product rule. So we have 3 squared times 2 squared inside our log. And the product rule tells us that we can split this into 2 logs. So this is going to equal log of 3 squared plus log of 2 squared. Next, we're going to use our power rule to pull the exponent down in front of the log. So that means log of 3 squared is equal to 2 times log 3. And log of 2 squared is going to be 2 times log 2. And now we have rewritten log 36 in terms of log 3 and log 2. So we have our log 3 here and our log 2 here. We're given log 3 is equal to a, so this is equal to 2a. And then log 2 is equal to b, so this is just 2b. So therefore, log 36 in terms of a and b would be 2a plus 2b. Now the last rule we're going to cover in this video is the change of base rule. So the change of base tells us that if we have log base a of b, we can actually rewrite that as log base c of b divided by log base c of a. And this c here can be any number of your choosing. So essentially, what this rule says is that we can use the change of base rule to pick our own bases because it always computes to the same value. So at the beginning of the video, I said that for product and quotient rule, you can only use them when we have the same base. So this change of base rule will help you when you actually get two expressions with different bases. So let's take a quick look at an example. Suppose that we have log base 2 of 5. So that is equal to this decimal number here. So now we want to use change of base and rewrite this, let's say, in terms of base 10. So change of base says that this is going to be equal to log base 10, which we don't have to write the base. So that would be log of 5 divided by log of 2. And notice how it's the same. And we can actually go ahead and pick another base. So let's say we want to pick base 4. So then this would be log base 4 of 5 divided by log base 4 of 2. And again, we get the same number. So regardless of which base you pick, you will always end up with the same number. And that is the beauty of this change of base rule. So now we can go ahead and use this change of base rule to evaluate these expressions here. So we have log base 6 of x is equal to 6. And then we have these three different expressions that we want to find the value of. The first one is log base 1/6 of x. So this, using our change of base rule, of course we can pick any base we want. But because we're given that log base 6 of x is equal to 6, then we want to use base 6. So we can write this as log base 6 of x divided by log base 6 of 1/6. Our numerator, that's just equal to 6 because that's what we're given. And our denominator is going to be equal to -1 because 6 to the power of -1 is going to give us 1/6. So therefore, this is equal to -6. The second expression is log base 36 of x. We're going to do the same thing. We want to use change of base and use base 6. So this is going to be log base 6 of x over log base 6 of 36. Again, our top is just equal to 6. And then our bottom is going to be equal to 2 because 6 to the power of 2 is 36. So our answer here is equal to 3. And now the last one is log base of square root 6 of x. Do the exact same change of base. We get log base 6 of x over log base 6 of square root of 6. Our numerator, again, is 6. And then the denominator, if you think back on your exponent rules, 6 to the power of 1/2 is going to give us square root 6. So this is 1/2. So now 6 divided by 1/2 is going to be equal to 12. So now let's do a quick recap of everything we covered in this video. We learned how to read and understand the 4 most important log laws and how to use them in basic problems. So those are your basic building blocks. And now it is your turn to give this a try. Suppose that we have log a is equal to 1/3, where a is greater than 0. Can you evaluate the following without a calculator? Make sure to leave your answer in the comments below and let us know if you'd like to see more content on logs in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.